All right, good morning. We are now recording. If I can get the current slide to come up. And can I get your name, please? Jackson, got it. Kenesha, right? Okay. Anyone else coming since the call roll? All right. Now, let me say this again, not because of you who just came in, but because I forgot to record it the first time. As of Wednesday, I'm supposed to read a little script to you today. I forgot to bring it up here. It's about how you have to complete payment and that kind of stuff. I'll try to remember to bring it on Wednesday and read it to you then. The Vice President has us doing all these things, okay? But anyway, if you have not completed payment, please do so by Wednesday, because they will be removing unpaid students from the roll as of Wednesday. Now, if the payment's in the works and you know it's coming and you've been coming to class, okay, please get in touch with the business office and let them know what your status is. They can put a flag on it and keep them from removing students who are serious about, who have been coming and are serious about coming. So please do that. But the better thing is get paid. Can I get your name, please?
Essence.
Huh?
Essence.
Essence, right. Okay. Does anyone else come in since I called roll? Okay. All right. The only other announcement is I was going to, first, if any of you are interested in coming and seeing what the math team's about, I know most of the math we'll be doing is a little beyond this grade level, okay, but you can still maybe get boned up, beefed up for upcoming course and help yourself out there. But I think we're going to start our practices today, Mondays and Wednesdays, 3:15 until 4:45, I believe it is. We may not go the whole time because we'll just go as long as people want to continue. You can come for any part of it, that's perfectly fine. The other thing is, and this really doesn't affect my office hours any, I don't think at all. We do have a meeting scheduled for Friday. Normally my office hours on Friday are 7:45 to 11:45, but if I'm not mistaken, they've done us the big favor of scheduling the meeting at 12:30. So that won't affect my office hours any. It just makes me later than what I'm supposed to be here, but that's beside the point. So, but if you are looking for me after 12:30 on Friday on the Birmingham campus, I'm going to be in the ACAP building in a meeting, so hopefully that won't last too long. But normally I'm not there at that time anyway. All right, any questions over anything we've covered so far? All right. The last thing we covered was factoring trinomials that have a leading coefficient of 1. And they were pretty easy, pretty straightforward. Now we're going to allow a leading coefficient other than 1. A can be anything other than 1. Well, and it can be 1 too, but we're going to go from there. All right. We've been factoring trinomials in the form this, where your leading coefficient is 1. That is trinomial blah, blah. Okay. Now, let's consider factoring trinomials where it's not 1. First, let's illustrate an informal trial and error technique that works quite well for certain types of trinomials. This technique is based on the knowledge of multiplication of binomials, just like we did before, so we might need to do that multiplication again. Do you need to review foiling? We've already been unfoiling. So I think we're okay, aren't we? Okay. This is on top of page 161, section 3.6. Okay? Example 7. All right. Now what we're going to hope, there's a lot of hope here, right? Goodness gracious, there it is. Okay. Got to get my pen. Boy, the system's slow today. This is a lousy, it's a cheap system. That's why the school uses it. Sorry about that, but we had a pretty good system, but they didn't like to pay for it. All right, we're going to hope, if we can get this thing to right. Okay. Anytime now. This is really slow. There we go. Okay. All right. We're going to hope we can factor this into two binomials. What my approach is, and it's sort of silly probably, but whereas you multiply two binomials by foiling, I say let's unfoil this. Okay? So let's start with the first term. What's the only possible factorization for 2x squared? Say again? Okay, 1x times 2x. So x times 2x. Everybody agreed? Same thing we did before. Where do we look next? The sign of the last term. Okay? Not quite spelling it unfoil right, but the sign of the last term. What's that? What does that mean about these two terms? They've got to be the same. What do they have to be? 2 minus? Plus, because the middle term is plus. Okay? So we're going to have plus and plus. All right. Now remember they called this a trial and error method. Okay? Here's where the trial and error comes. What's the only possible factorization for 5? 1 and 5. You want to try it in that order? 1 and 5. How do we know if it's right or not? Foil it, exactly. And when you foil x times 2x, you get 2x squared. Of course, we knew that one would be right. 1 times 5 is 5. X times 5 is 5x. And 1 times 2x is 2x. 5x plus 2x is 7x. Wrong number. If the number's wrong, change the numbers. Okay? So swap the numbers. Let's make the first one the 5 and the second one the 1 and see if that works. Make this 5 and this 1. Now we go back and foil again. Still x times 2x is 2x squared. That still works. X times 1 is 1x. Plus 10x is 11x. And then 5 times 1 is 5. So that is the correct factorization. See how it works? You may make a mistake the first time on your first guess. Keep guessing. Okay? Now, some of these may get into very large number of guesses. This one wasn't. Here's the key here. This one only have one possible factorization for the first term and one for the last term. So you have at most, in this problem, only 2 combinations. We did them both. If the signs are a little different, you might have 4 combinations. But that's still not too bad. Okay? When you have multiple factors here and multiple factors here, then you might want to try another method. And we'll show you that a little bit later. Any questions on this? All right, let's see how they did it. By looking at the first term, 2x squared, and the positive signs of the other 2 terms, we know the binomials are of the form x times 2x, yes, plus times plus, yes, we got that. All we have to do is get the 2 constants. And that's where we were basically before. And we tried 1 and 5, and then we tried 5 and 1. Okay? Because the factors of the last terms, 5 or 1 and 5, we have only those 2 possibilities to do, and you foil them both. We found out this one wouldn't work, that one did. Okay? By checking the middle term formed by each of those products, find the second possibility yields the correct middle term of 11x. Now what if, and here's Tara. I do apologize for my horses today. I went to the UAB game Saturday, so sorry about that. Okay. So we found out that's the second possibility, that the 11x was your possibility there. That was example 7. Any questions on this? This is, by the way, on page 161, section 3.6, factoring trinomials. Any questions? Okay. Now they do it. Therefore, when you factor it that way, you see, and reform it, you see you do get the right answer. All right. They're skipping examples 8 and 9. So let's go back and do examples 8 and 9. Let's do them here. Okay? Here's 8. 10x squared minus 17x plus 3. All right, where would you begin? Let's first just assume it is factorable. Oh, and I meant to say this on the last one too. Can you get your name, please? Brianna. Got it. All right, anyone else come in since the called roll? Okay. I meant to say this on the last one. When you do your factorization and you try trial and error and you get nothing to work, it could be it's not factorable. Okay? I think I went over this before too. But not factorable as an answer on a quiz or a test, it could be. But just because you can't factor it doesn't mean that's the correct answer on the test. It's got to be truly non-factorable before that'll work. But let's try this. There's several factorizations of 10x squared. I can think of 4 right now. Okay? Pick one. 2x and 5x. Okay? 2x, 5x. Okay? Now, where do we look next? Sign of the last term. What is it? Positive. What does that tell you about these two terms? They've got to be the same. What does this tell you? They've both got to be negative. Very good. So minus and minus. Now, what's the only factorization of 3? 1 and 3. So let's try that. 1 and 3. Let's see what we get. We got to see if we get the middle term. We know we got the first term right and the last term right. It's the middle term that bothers us. So 2x times 5x is 10x squared. 2x times negative 3 is negative 6x. Minus 1 times 5x is, and negative 6x plus negative 5x is negative 11x, not negative 17x. Wrong answer. Get your name, please. JT. Jason? JT. JT. Okay, got it. Okay, I didn't remember Jason in the class, so I was going to look. Okay, JT, got it. Okay, so that one doesn't work. And it's the wrong number. So we're going to change some numbers. What number would you choose to change? You can either swap the 1 and the 3, the 2 and the 5, or choose a 1 and 10 or 10 and 1. Okay? Several choices. You give me something. What you want to try first? Say again? 1 and 3. Let's try that one first. We'll make that the 3 and that the 1. Okay? Oh, someone's pretty clever, huh? What does this give us? 2x times 5x is 10x squared. That's right. Minus 2x minus 15x. Ding, 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 ding. Negative 17x plus 3. You got it. Okay? So if the first trial, this is trial and error. The first trial gives you an error, try something else. If it's only a sign error, change signs. If it's a number error, numerical wrong number, then hang up and dial again. No. Then you change the numbers. Okay? And you have to keep changing until you got all the possibilities and then say, hey, I see none of these that'll work. Now, we'll get to that other method coming up in just a little bit. Okay? Any questions on that one? All right, let's try this one. 4x squared plus 6x plus 9. Now, actually, they should have waited on this one, but we'll do it. Where would you like to begin? Let's just first assume it's factorable. How would you like to start? Couple of possibilities. 2 and 2. So 2x and 2x, is that what you meant? Okay, then where do you look next? Sign of the last term is positive. That means these two have to be the same, and because the middle term is positive, they have to be positive. What's one factorization for 9? Say again, 3 and 3? Is that what you said? Okay. That looks pretty good until we try it. And what happens? 2x times 2x is 4x squared. That's good. 2x times 3, 6x plus 6x is 12x plus 9. Nope, that one's not going to work. Okay? How about any others? Wrong numbers, so we're going to have to try some new numbers. Say again? What you want to change? You can't swap 2's and 2's, that won't give you any difference, or 3's and 3's, that won't give you any difference. So what? Say again? 9 and 1. Okay, we'll try that. Okay, in that order. 9, well, it doesn't matter, does it? Okay, let's see what happens there. Whoa, even worse, isn't it? 2x plus 11x. Oh, plus 18x. That's 20x. We're getting even further from the truth. Okay? Now, here is the key, folks. I think you just saw it, whether you realize it or not. Let's try it. Say again. 1 and 4. Let's try that one. Okay? Okay, what does that give us? Even worse. Second? Okay. Let me give you a hint. When you keep the smaller numbers in there, and that's the first you chose, 2 and 2 and 3 and 3, those are the smallest numbers. When you did those and your middle term still came out too big, there's a good chance this one's not factorable. But if you don't want to take the chance of getting that wrong, we're going to do this when we move to chapter 6. But I'm going to show you now because you're already familiar with it. Does anyone remember that cute little thing called the quadratic formula? Yes, remember the thing that's in the radical there? It's called the discriminant. Remember that? No. Okay. Let's see. We haven't done quadratic formula, but I was hoping you had done it sometime in your storied past. Okay? How the quadratic formula goes is minus b plus, this is x equal minus b plus or minus the square root of b squared minus 4ac. All divided by 2a. Now, we're not going to do anything with all that. All I'm going to ask you to do is to consider what's in here. If this comes out to be a perfect square in here, then this thing is factorable. If this thing in here does not come out to be a perfect square, it's not factorable. So this is a really fairly quick and easy test to do. Do you know what the A, B, and C stand for? Anybody? Yeah, this is the A, that's the B, that's the C. Remember, because it's AX squared plus BX plus C. So the B is 6. And 6 squared is? So here's all we're looking at. B squared minus 4AC. So this would be 6 squared minus 4 times 4 times 9. Okay, 6 squared is 36. minus 16 times, well, okay. These two multiply to be 36, right? 4 times 9. 4 times that is going to be huge, 100 and something another. Guess what? This is not even going to be positive. You can't take the square root of a negative number. So as soon as you see that, whatever that turns out to be, 36 times 4. Say again? Did someone do it? 144? Okay. Minus 144. What in the world is it doing here? Okay. All right. Look at this thing. It's going crazy. All right. Okay. Wow. This comes out to be negative 108, I think. Whatever it is, it's a negative number. You can never take the square root of a negative number, not in the real number system. So this one obviously, maybe not obviously, but it's not factorable. Not factorable. Okay? And that's a good little test if you want to use it to see if it's not factorable or not. Look at the discriminant, b squared minus 4ac. Just remember that. Write it down on a piece of paper. Remember, you can bring this to any test that you want to. So write down b squared minus 4ac. If that turns out to be a perfect square, you know this is factorable. If it doesn't turn out to be a perfect square, like if that would have been positive 108, that's still not a perfect square. 100 is a perfect square, 121 is a perfect square, but 108 is not. So therefore, that would have been possible, factorable anyway. Okay? So this one is one of those that is not factorable. And after a while of trying all the combinations, when you get there, this is a little quicker. If you try a few and say, this doesn't look promising, jump to that b squared minus 4ac. The book doesn't tell you that yet, but I'll tell you that for free, okay? And it's just an easy way to go. Any questions on that? Okay. All right. Now we're going to look at another method for factoring, especially when A and C have multiple factors like that last problem did, and actually the one before. If you don't want to sit there and try all the possibilities, here's another method. Now, their description of it, to me, leaves a lot to be desired. After a while, it just sounds like blah, 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 okay? So, but now it's obvious that factoring trinomials of this one can be tedious. Oh, no kidding, okay? The key idea is to organize your work so you consider all the possibilities, okay? But there get to be a lot of them. Like that last one we had, 2 times 2 and 3 times 3, or 2 times 2 times 9 times 1, or 2 times 2 times 1 times 9. And 4 times 1 times 3 times 3, and 1 times 4 times 3 times 3. You get a bunch of possibilities, and you may get tired of trying to consider them all. We suggested one possible format in the previous example, that you string them all out there and see. As you practice such problems, you may come across a format of your own. The lady who used to teach in the room right next to me here, Miss Mary Stringfellow, fantastic teacher, and she had a method called the scissors method, and the students loved it. And I let her retire from here and never got to find out how she did the scissors method, you know. So if you can find the method, something you learned in high school, go for it. If it works, go for it. Okay, whatever works best for you is the right approach. There is another, more systematic technique you may wish to use, considering with some trinomials, and here's what it is. Now, of course, I gave you first. You know, you can see whether it's factorable or not. The other thing really, it does maybe help you see how to factor it, but here's the part that gets really blah, blah, blah-ish, okay? When you have px plus r times qx plus s, oh, what fun letters, okay? And you were going to FOIL this, the first gives you px times qx. The outer gives you pxs, the inner gives you rqx, and the last gives you rs. Okay, we know how to do that. We know that, okay? And your middle term is PS plus RQ times X, okay? Yeah, we see that. So note that the product of the coefficient of the X squared term and the constant term, the X squared term and the constant term is PQRS, okay? And likewise, the product of the coefficient of X is PS times RQ. And you multiply those two together and you get PQRS, okay? Yay, okay? That looks interesting. Therefore, when we're factoring the trinomial of this form, the two coefficients of X must have the sum of PS and RQ and the product of PQRS. Yay, okay? That sounds really interesting, doesn't it? Okay? Let me do it a little simpler. All right, at least I found it simple. If you like that, go for it. The book does it. It uses that example. This is doing the same thing, but I find it just easier to deal with. And it feeds right on what we were just talking about and what we're going to talk about later. And that is, name these coefficients A, B, and C. Okay? Now this is doing the same thing they just said, but to me a lot simpler. It's called the AC method. Multiply A times C. In this case, what is it? Multiply it together, yeah. What do you get? Negative 60. All right. Now your B is negative 11. All right? Now what we were just saying before, the product of these two things, the PQRS they said before, has to be, when you break it out, has to add to negative 11. Okay? So, the product is negative, the thing is negative. Now, if the product's negative, what does that tell you about the two factors? One's positive and one negative. Which is going to be the larger value? If the sum's going to be negative. The negative. Okay? So what we're going to do is do all the possible factorizations of negative 60 and see if they add to be negative 11. And remember, the larger number has to be the negative. So the first, the simplest, and we know it doesn't work, but I'll just show it to you, 1 and negative 60. That multiplies to be minus 60, right? But it adds to be minus 59. That's not negative 11. Okay? Forget that one. Next one, 2 times what? Negative 30. Okay, that multiplies to be minus 60. Can I get your name, please? Minuet, got it. There you are. Okay. We're somewhere around the bottom of page 160, top of one. Well, we're on the top of 160. Wait a minute. No. Bottom of 161, top of 162. We're doing example 10 on 162. Okay? What do these add to? You can add them, right? Negative 28. That's not negative 11. Forget that one. Next number? 3. What would be its other factor? Negative 20. Now notice here we're getting closer to negative 11. Let's see what we get here. Add those two. Negative 17. Still not negative 11, but we're getting closer. Next number will go into negative 60. 4 times negative 15. Add those together, and what do we get? Negative 11. Ding, 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 ding. We got it. A winner. Okay? Now, what do we do with that? Okay? Here's what we do with it. We write down our first term, 6x squared. And instead of writing minus 11x, we write plus 4x minus 15x. We just take these and make those the coefficients that add to be negative 11. And then we do minus 10. Now that actually looks worse than what we had to begin with, doesn't it? Except for this. What technique can we use on that? Second, grouping, exactly. Let's group these terms. Okay? And then what do we look for in the groups? Second? You probably. GT. What does that stand for? Exactly. Okay, I want to make sure that I was hearing you right. Greatest common factor. What's the greatest common factor between 6x squared and 4x? 2x. What do you have left? What do you have left when you factor out a 2x? 3x. Help me. Plus, what do you say? 2. Got it. All right, the next group. What's your GCF there? Negative 5. And what do you have left? No, you pulled out the minus. 3x plus, second, 2. Hey, that's looking pretty good. What do you have now? You have a binomial factor, so factor that out. 3x plus 2, and what do you have left? 2x minus 5. All right, there we go. That should give it to us. Let's check it and see. 3x times 2x is 6x squared. Fantastic. Then we have 3x minus 5 is negative 15x plus 4x. Yeah, that's going to be minus 11x and minus 10. We got it. Okay? So that's a way to do it if you don't want to try all the possible combinations. You notice here, what were your combinations here? 1 times 6, 2 times 3, 3 times 2, and 6 times 1. Over here you have 1 times 10, 2 times 5, 5 times 2, and 10 times 1. And then you had all the sign changes. Okay? So yeah, you could have spent quite a bit of time. If you're very lucky or guessed well or really insightful, maybe you got it on your first or second try. If you did, that's easier than this one. If it took you 4 or 5 tries, I think this one's easier. Okay? The other thing about trial and error, you get lost in your trials. This is very systematic. Okay? You just go down the thing. If you pick the smallest numbers first and go, you generally aren't going to skip it. And here's the key. Here you always start too big, in this case too small, very negative. You work down getting closer to this. If you had skipped over this, then you stopped and say non-factorable. If you included every possibility and you skipped over that, you say non-factorable. But this one we didn't. We hit it right on the nose, so it was factorable. Does that make sense? Now this book doesn't call it AC method. It calls it something else, but it's really doing the same thing. Why do I call it AC method? Our discriminant uses that form. The title of this section uses that form. Everything you do with polynomials uses A, B, and C, not P, Q, R, and S, okay? To me, that just is extra stuff, okay? I don't find that beneficial. But if you like P, Q, R, S, by all means use it. It works. We did almost the same thing. Any questions before I delete it? Okay, let's see how they did it. Okay, multiply the coefficient of the x squared term, 6, by the constant term, negative 10, and you got negative 60. Exactly what we did if you call it the AC method. A is 6, B, yeah. That's exactly how we started. Okay, and then we find 2 integers whose sum is negative 11 and whose product is negative 60. And it says it'll be helpful to make a listing of all the factorial pairs for 60. Why not go on and include the sign with it? Okay, You know that one of them has to be positive, one negative, and the larger value has to be negative. So start doing that. Just put the small numbers to be here and the negative numbers to be larger. They're going to start and go down the list, and they go all the list, okay? Well, guess what? Why go all the list if you had put the signs in there when you got the 4 and minus 15, you got it, you're done. Who cares about 5 and 12 and 10 and 6, 6 and 10? Who cares? I mean, why do extra, okay? So if you put your signs in there and do your subtractions, because the product from step 1 is negative 60, we want pair of factors, absolute value of the difference is 11. Okay, if you started off doing it properly, you wouldn't have even had to have that sentence in there. But it sure enough is 4 and 15. But then you have to put the signs in the right place. Start off putting them in the right place. Positive 4, negative 15, that adds to negative 11. Seems like their way is way too long to do the same thing that we did. It's right, but you have all these extra steps in there where you could make errors really easily, okay? So you rewrite the original problem just like we did, okay? Here was the original problem. Now notice here, we did it wrong, didn't we? We put plus 4 and minus 15. They put minus 15 and plus 4. Does it matter? Not a whit, okay? Not at all. Just group these two together and group those two together. Let's do it. Let's see what happens. Group these two and group these two, okay? Cole? Andrea? Okay, good deal. Okay, we're working on example 10, top of page 162. By the way, let me just say this again, not that any of you people who just came in it's pertinent to, but just so you've heard it. We're supposed to actually read it, but I forgot to bring in the script to read. The business office or administrative part or whatever is going to remove all unpaid students from the roll on Wednesday. So if you haven't paid or you have friends that have not completed their payment, please let them know they need to get something done by Wednesday. Even if you can't pay it all, get in touch with the business office, tell them what your status is, tell them what you're working on, convince them that you are going to pay, and they may not remove you from the roll. But even if they do and you come up with payment later, usually you can talk your way back in. But it's a lot of extra work. If you can get it paid by Wednesday, please do so. Today's better. Tomorrow's not quite as good as today, but better. But waiting till Wednesday is really cutting it to the very end. So try to get everything done as soon as possible. Okay? So please tell your friends. All right. We grouped. What do we do with the first group? Factor out the greatest common factor of 3x. And what do you have left? 2x minus 5. Next group. Second. 2. And what do you have left? 2x minus 5. Okay. And what do you find then? You have a greatest common factor is the binomial. Factor that out. 2x minus 5. And what do you have left? 3x plus 2. We got the very same thing, just in a different order. And it doesn't matter on the order. So yeah, it didn't matter which one you put first, it still should work. Okay? Any questions on that? Okay. And that's what they did. And sure enough, they got their answer is 2x minus 5 times 3x plus 2. Very good. Same thing we got, we just got them in reversed order. Both answers are correct. Any questions? And they wrote it then again. I think it's a good idea to pull it and make sure it's right, that you didn't miss a sign or miss something when you were doing it. But you're pretty much Doing it this way, doing it carefully this way, you really have a good chance of getting the right answer on the first try. Good deal. Any questions? That was example 10. They are skipping 11, so let's go back. And do 11. 4x squared minus 29x plus 30. Now you tell me what method you want to use. I only know of two right now that we've discussed in detail, trial and error and AC method. Which do you prefer? Trial and error, did I hear? Okay, we'll try trial and error, okay? What trial do you want to try first? Second? Only possible factorization of 4x squared. 2x times 2x, okay? Where do we look next? Sign of the last term, what is it? Positive. What does that tell you about these two signs? Got to be the same. What sign do they need to be? Minus, negative and negative. Okay, possible factorization of 30. Say again, 30 and 1? Is that what you said? Think that's going to work? Let's try it. 2x times 2x is 4x squared. Good so far. Minus 2x minus 60x. It's minus 62. Not quite negative 29. So that one's not going to work for us. What might we try next? You want to do trial and error? Let's do it. Next, what you want to change? Change the factorization of 30 to what? I thought I heard 5. So again, 5 times 6. Okay, let's try that. 2x times 2x, 4x squared, that still works. Minus 12x minus 10x. Minus 12x minus 10x is minus 12x minus 10x is negative 22x. Closer, but not there. Second? 10 and 3. Okay, let's try that one. 10 and 3. All right. 2x times 2x is 4x squared. Okay, happy there. This gives you minus 6x minus 20x minus 26x. Closer, but still not minus 29x. Say again? Well, we don't know, do we? We haven't exhausted all the possibilities. So you see, here's the problem with the trial and error method. You can work for quite a long time and still not sure you have exhausted all the possibilities. You want to try AC? 2 and 15. Say again? 2 and 15. Okay. All right, we'll try 2 and 15. Now, I'll tell you right now, this won't work. And the reason is, this has a common factor of 2. And if that had a common factor of 2, this would need to have a common factor of 2. It doesn't. So, it's a good guess, but because of that, you know it can't. And we'll check it and see. 4x squared minus 30x minus 4 is minus 34x. Yes. Second? Well, that doesn't work. You raised your hand, so.
I was doing AC method.
Okay, let's try the AC method. All right. So let's erase this and try AC method. Someone remind me, what does AC stand for? Or what is AC here? It's what? Action? Okay. 4 times 30, which is? 4 times 30? 120. Okay? And then your B is minus 29. Okay? Now we want two numbers that multiply to be 120 and add to be minus 29. Well, we know the signs have to be negative and negative. So let's start. And this isn't the best place to start, but it is most systematic. Minus 1 times minus 120. We know right off the bat that's going to add to minus 121. Way too much. So let's try the next one. Next one. Negative 2 times negative 60. That adds to negative 62. Still too great, but it's coming down. Okay, next. Okay, let's try the negative 3 times. Yeah, I know you're jumping ahead and it's good. Negative 3 times negative 40. That adds to negative 43. And that's still too big. Negative 4 times negative 30, and that adds to negative 34. Getting closer, and I think you're right. Negative 5 times negative 24, and guess what? Ding, 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 minus 29. You got it. So yeah, if you can jump to it and see it right off the bat, do so, okay? Or if you want to be more systematic about it, do along. Sure enough, that gives it to you. Where do we go from there? 4x squared negative 5x negative 24x plus 30. Okay? That adds to be minus 29x. So you're okay. What do you do now? Group. What do you notice about the first group? Pull out an x. Factor out an x, and what do you have left? Say again? 4x minus 5. And in the next group? Negative 6. And what do you have left? 4x minus what? 5. Perfect. Now what do you do? A little louder. 4x minus 5 is a common factor. Pull it out. And what do you have left? X minus 6. There we have it. So we could have gotten there if we'd have kept doing trial and error, I think, if you had not missed that one. But you see, the problem here, you had so many different factors. 1 times 6, I'm sorry, 1 times 4, 2 times 2, 1 times 30, 2 times 15, 3 times 10, 5 times 6, and then 6 times 5. I mean, you had all those different combinations. This method systematically takes you through those, find out if you did. If you're going down the list, not skipping anything, and jump past from minus 34 to minus 28, you know you can't get negative 29, then there's no factorization. But if you hit them all, and they keep getting smaller or closer, and then you finally get there, that's your factor. That gives you what to do. If you don't get that number, then you know it's not factored. Okay? So the other way, you never know if it's not factorable until you're absolutely certain you've exhausted all possibilities. This way, you know it's not factorable if you're going down the list and you skip over the number you're looking for. Because they start absolute value too big and start getting closer, and if you skipped it, then it's not factorable if you did everything right. All right. And they got 4x minus 5 times x minus 6. Good for them. Okay, any questions on that before I move on? Any? Okay. All right, they sure take a lot of steps, don't they? Okay. Now we're going to move to factoring perfect square trinomials. That's what I thought one of these was earlier, and then I saw it wasn't. Perfect square trinomial. Okay, let's start with this. Give me a letter, any letter. Second? A. Give me a sign, plus or minus. Plus. Give me another letter, any letter. Oh, wow, very creative. Okay. Let's square that binomial. A plus B squared. Anyone remember the easy way to do it? Both ways are easy. One's a little shorter. How do you do that? Anyone remember? Second? No. Just to square that binomial. It's going to be an expression. AB squared, is that what you said? A squared. Okay, I heard a plus B squared. Is that all? Say again? Plus AB. Close, but no cigars. 2AB. Okay? If you don't remember the shortcut, do it the other way. This means A plus B times A plus B. That's what it means to square something, multiply it by itself, right? Now let's FOIL that. What do you get? A squared plus AB plus another AB plus B squared. So that's A squared plus 2AB plus B squared. So the shortcut is square the first, twice the product, square the last. That's the shortcut. But if you don't remember the shortcut, FOIL it. You know how to FOIL. It should give you the right answer. So guess what, team? If these two multiply to be that, then this factor should be that. How can we recognize that as a factor, what they call a perfect square trinomial? Well, what we noticed, the first term's a perfect square, the last term's a perfect square, the middle term is twice the product of the two. Exactly how we got it. So if you recognize that, then you know how to factor perfect square trinomials. If this isn't a perfect square, or if that's not a perfect square, don't even try it. But if these two are, and then this happens to be twice the product of those square roots, then you've got it. Okay? Now, they're going to do the same thing here. And also it works if you're giving me a minus here. Notice what that would be. A squared minus 2AB plus B squared. Always the first and the last terms have to be perfect squares, meaning both positive. The middle term can be the positive or negative, but it has to be twice the product of the two. So this will factor to this, A plus B times A plus B, or A plus B squared. And this will factor as A minus B times A minus B, or A minus B squared. Those are called perfect square trinomials, result of squaring a binomial. How you recognize them? First term's a perfect square, last term's a perfect square, the middle term is twice the product of the two. Okay? That's the shortcut. You can always factor perfect square trinomials using the usual techniques, unfoiling, AC method. Everything works. But here's what we look for. This is a perfect square. Square of 2x. That's a perfect square. Square of 3. Well, 2x times 3 would be 6x. Double that, you got 12x squared. 12x, yeah, you got a perfect square. So the first term has to be a perfect square, meaning positive. Last term has a perfect square, meaning positive. The middle term could be positive or negative, but it has to be twice the product of these two entities. And sure enough, it is. If that's the case, you got a perfect square trinomial. It'll be 2x plus 3 squared. Okay? Or 2x plus 3 times 2x plus 3. But guess what? They're easy to unfold as well. Okay, how about this one? Is this a candidate for a perfect square? Yes. Is that a candidate for a perfect square? Yes. What's the square root of this? 3x. Square root of that? What's 3x times 5? 15x. That's exactly double it. So it's got 3x minus 5 squared. Wherever it is, they have on the next page. Okay? 3x minus 5 squared, or 3x minus 5 times 3x minus 5. Okay? And there we got it. 3x minus 5 squared, or 3x minus 5 times 3x minus 5. Okay. So let's do a few of these, if they're doable. How about the first one? Is that a possibility? Is that a candidate? What you think? No? Is this a perfect square? What you think? Yeah, okay. X, okay. Is this a perfect square? Yeah. The sign is plus, so let's try x plus 7 times x plus 7. I like to write it that way because it's easier to form. Let's form it and see what happens. X times x, x squared, x times 7, 7x, plus 7x is 14x, and 7 times 7 is 49. Yeah, that's it. Okay. Is this a candidate? Yes. Is that a candidate? Yes. So let's try it. N minus 8 times n minus 8. Let's see if it works. N times n is n squared. Minus 8n. Minus 8n is minus 16n plus 64. Okay. How about this one? Is that a candidate? Yes. Is this a candidate? Yes. Well, let's try it. What would be the square root of the first one? 6a plus 5b. And let's see if that works. 6a plus 5b. 6a times 6a is 36a squared. Very good. $30ab plus 30ab is 60ab plus 25b squared. Right? Perfect. Square. Trinomial. Okay, how about that last one? I know it's getting messy. Okay. This a possibility? Yes, what would that be? 4x. Is this a possibility? What would that be? Plus y? Oh, did I do it right? No. Needs to be a minus y. Okay? Why? Why minus y? Because the middle sign's negative. 4x minus y. Let's follow it and see. 16x squared, that works. Say again? Minus 4xy, and another minus 4xy is minus 8xy plus y squared. Yep. Works fine, doesn't it? Those are pretty easy if you look at them and say, hey, that may be a perfect square. If that middle term doesn't come out right, it's not a perfect square trinomial. So don't force it, okay? But if it does, you got it. Any questions before I delete it? Okay. Let's see what they do. On the first one, okay, they write it out in long form. They say this is a perfect square of that, this is a perfect square of that, and is that middle term twice the product of this and that. X squared plus 14x, yes, plus 49, yes. If you like doing it this way, do it that way. It's perfectly fine, okay? You just have to sort of go a little backwards on it, but it's fine. Let's look at this. X plus 7 squared, which is just as good as x plus 7 times x plus 7. There's no preference there. Now, and I apologize for those who've been asking about WebAssign. Not last Friday, but the Friday before that, there were the Cengage, the people who published the book, were on campus, on the Birmingham campus. I went to them and said, do you have your technical support person here who can set up a class, for me? Oh, yeah, he's here. Well, we're in a meeting now, but we'll have him stop by before he leaves. I wasn't in the meeting. That was for social and behavioral sciences. So they met with them, and then they left without stopping by to see me. He said he would get it done Friday, and he didn't. And then last Friday, the dean had a meeting and ate up almost the whole day. So I didn't get it done last Friday either. So I'll try if I can this afternoon. But if we have math team, I don't know if I'll have time this afternoon. Because today I've got to leave right at 5:15. I'll have a meeting at 5:30. I'm not going to be there on time for it, but I'll leave as soon as I can. Okay, so I'll try to get it done today. But here's what I was going to say. If you had WebAssign, and this was a homework exercise, and you put down x plus 7 times x plus 7, it's going to tell you it's the wrong answer. It's not a wrong answer. It is. If they're looking for that answer, then WebAssign only accepts that answer. That's why I don't like using WebAssign. It tells students they got wrong answers sometimes when they have right answers. And actually, if you, on earlier ones, if you had done it, say 3x minus 5 times x plus 2, and they were looking for x plus 2 times 3x minus 5, it'll tell you have a wrong answer. You have to guess what they're looking for. And if they only have so many guesses and you don't get it, they tell you it's wrong. It's not wrong. That's why I don't like WebAssign. But I'll still try to get it done for you. Okay, sorry about that. It's my little soapbox. Oh my goodness. We're almost out of time. This one, perfect square, n squared, perfect square 8, and the middle term is twice the product. Perfect. Okay? Or n minus 8 times n minus 8. Here on perfect square 6a, 5b, and the middle term is twice 6a times 5b, 60ab. Okay? And this one, 16x, y, and twice 4x times y would be ax, y. All right, good deal. Now, that took us through that. We're almost at the end of the section. The next part is summary of factoring techniques. We'll start that on Wednesday. However, you have now completed most of what you need, maybe all of what you need for the first quiz. So I have it ready, and I'll give it to you. It's not due until we finish the section, which will probably be Wednesday. Okay? So, you get an extra couple of days to work on it. All right? If you don't want to take it now, you don't have to, but why not? You're willing to take. Pass 2 across. Pass 1 across. Also, I need to give you a homework assignment too. I didn't want to forget that. exercises. Any of the odds 1 through 29, any of the odds 31 through 55, any of the odds 57 to 61, and any of the odds 63 through 99. No, 111. Okay? And we'll do the summary next time and do a little bit in 3.7. Good deal.